This is going to be a walkthrough video of the Exam 2 review. And as a reminder, you will have a different number, different value than I do, but you can follow along the same process that I'm using to get your answers. So let's start with the first problem. So here we need the absolute change and the percent change in the following case. So in this problem, for absolute change, the formula is new minus old. So we need to figure out our new value and our old value. Now, if you are given a time frame, the most recent year is always the new, and the other year that is being compared to is what your old. So we have February 2013 and February 2008. The most recent year is February 2013. So the price that goes with that month and year is our new, and 311,000 in February 2008 is our old. So new minus old, 156,000 minus 311,000. This gives an absolute change of negative 155,000. Now, the next one is a relative change, and to find relative change, this is new minus old over old, and you always have to multiply by what? 100. Okay, relative change is also a percent change, so do not forget to express it as a percentage. So new minus old is what we found on the first part, that is same as the absolute change. We have 156,000 minus 311,000. Divide that by your old value, which is 311,000, and you express that as a percentage by multiplying by 100. So you end up with negative 155,000 divided by 311,000 and multiply by 100. And this gives, it says we have to round to the nearest tenth. So always make sure you're reading the instructions in blue, because that always tell you the form which you have to leave your final answer. So nearest tenth is the same as one decimal place, which is 49.8. Negative 49.8. Sorry, I forgot the negative. Negative 49.8. Now, 2, we are still looking at absolute and relative change. Now, for this problem, the new and the old value are given to us as a percent. Okay, so changes in percentage point. And we do not have to convert to the decimal. We have to use it as it is. So again, we have a time frame, which is 2000 to 2012. The most recent year is 2012. So this value is our new, and the 68% is our old. So new minus old, for absolute change, we have 87 minus 68. And this is 19 percentage points. Now, relative change, new minus old over old. And you have to multiply by 100. So 87 minus 68 divided by 68, and then times 100. You have 19 divided by 68, multiply by 100. And to nearest tenth, we have 27.9. Next, we have question 3. And here we need to select the correct answer below using the graph. All right, we have to describe the function shown on the graph. Now, we have to first get rid of some of the obvious wrong answers. All right, first of all, this graph is increasing. Okay, the line is increasing. So any keyword that has, or any sentence that has the keyword decrease has to be out. We have to get rid of that choice. Okay, and you can also make this bigger by using the maximize tool on the graph. So any decrease has to be out of the options. So A is out, B is out. Okay, so it's either C or D. Now let's look at the graph. Let's enlarge it and see how the graph is increasing. Okay, how the shoe size is increasing with respect to what? The height. Okay, so rise over run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the rise is 11. Rise over run. So the rise is 11. And the run is 10, 20, 30, 40, 50, 60, 70, 80. All right. So we are saying that the shoe size increases by what? 11. All right. So the 11 is the shoe size. And the 80 is the height in inches. So according to the function, shoe size increases by 11 every 80 inches. B is where we have to divide the two numbers we found on part A. So if we divide 11 by 80, and we have to leave our answer to 4 decimal places. Okay, so rise over run is the same as what your slope. Okay, how your y is changing with respect to x. So we are actually doing the math by dividing 11 by 80, and to 4 decimal places we have 0.1375. And the unit is shoe size. Okay, so 11, which is the y, which is the change in y, is shoe size. And the 80, which is change in x, is what? The height in inches. So this is size per inch. Now, to discuss the conditions under which a linear function is a realistic model for the given situation, the model is a rough approximation at best. All right, it's not very accurate because these are all predicted values, and we cannot say it's completely inaccurate. All right, it's close to the exact value. All right, but it's not exact. So the correct answer choice is the model is a rough approximation at best. Now, question 4, we have to find the rate of change of airplane altitude per minute. Now, in math, whenever you see per means divide. Okay, per means divide. So we have to divide something by something. So we are dividing the airplane's altitude by what? The minute. So the airplane altitude is 27,000 feet. And your time in minute is 15 minutes. Now this is where most students get it wrong, all right? They fail to introduce the negative sign in front of the rate of change. Okay, the word decline means the slope is what decreasing, or the rate of change is what decreasing. Okay, or the rate of change is what negative. So if you divide 27,000 by 15, we have negative 1,800 feet per minute. So the average rate of change, which is the same as the slope, is negative 1,800. Okay, the unit has already been provided, which is feet per minute. So you don't have to include that in the box again. Now, next we have to determine the slope from the problem. All right, the slope is a recurring change, and we are looking at how the tuition changes with respect to the number of credit. So over here, we have a slope to be $485 per credit. Okay, so that is the slope. And this means that the tuition increases by $485 per credit. Now, in order to construct an equation for the model, we need to know the starting value as well. All right, the starting value is the $20, which is the y-intercept. And if you write this equation using c as a variable, t is equal to, we have 485c plus 420. All right, linear model is y equals mx plus what b. Your y is the tuition, which is the dependent variable. The slope is the 485, how the tuition is changing with respect to the number of credit hours. X is your variable, the independent variable, which is what the credit. And your b is the starting value or the flat fee. So we have t equals 485c plus 20. And C, we can use this equation to predict the tuition, okay, the cost of tuition plus part-time student fee for 7 credit of classes. So what we do is, in place of C in this equation, we're going to plug in what? 7. This is $34.15. Now, question 6. The following situation can be modeled by a linear function. For a linear function, we have to use y equals mx plus b. So to construct an equation for the model, we need to find the recurring change, which is our m. So the recurring change on the problem is $10 per year. Okay, that is the rate. Okay, that is the rate of change. And we have the starting value to be the 12,000. So now we need to write this equation in terms of P and T. So do not write it in terms of Y and X. So your Y is a P, your M is a recurring change, which is A10. Your X is the time, that's the independent variable. And your P is the 12,000. So the equation here is P equals A10T plus 12,000. Okay, and the slope is positive because it says rises. All right, that's how we know the slope is positive. Now, to use this equation to predict the price of a car after 3.9 years, in place of T in this model, you're going to put 3.9. And this is $15,159. $15,159. Next is question 7. Now, the number of country household that paid bills online was 21 million in 2006 and has increased by about 7 million per year. Let N be the number of households that paid bills online at T years since 2006. We want to complete parts A and B. Now, is there a linear relationship between T and N? So here we are saying yes. And we have two of the yeses. We need to figure out which one is the right one. So we see increased here. So we have to go with the statement that has what increased. So we have yes, since the rate of change of the number of country households that pay bills online per year is a constant 7 million per year. That is a recurring change. Okay, this is how the bill is changing with respect to the time. So the slope is the 7. And to interpret that, the number of households that pay bills online has increased by 7 million per year. Now for B, we have to write an equation. So this equation has to be in the form y equals mx plus b, but we have to write this in terms of what n and t. So we already know the recurring change. So we have n is equal to 7t, and we have 21 million as our starting value. All right. All right, and again, the slope is positive because of the increase we see in the statement. And now using the equation, we can complete a table. So wherever you see t in the equation, you plug in the values under t. So if t is 0, your n is t times 0 plus 21, which is 21. If your t is 1, 7 times 1 plus 21. If your t is 2, 7 times 2 plus 21. Your t is 3, 7 times 3 plus 21. If your t is 4, 7 times 4 plus 21. So we have 21, we have 28, we have 9 plus 21 is 30. No, 7 times 2 is 14. 14 plus 21 is 35. 7 times 3 is 21. 21 plus 21 is 42. 7 times 4 is 28. 28 plus 21 is 49. I'm plotting a graph of n against t. So since our slope is increasing, the graphs that are decreasing are out. So we're going to eliminate graphs B and C. So this is either A or D. So let's see which one makes sense per the numbers we have on the table. So the highest value on the table for n is 49, and that has a time of 4. The lowest value for n is 21, that has a time of what? 0. So the graph that makes sense here is D. All right, question 8. We have 2 points where we have to find the slope. All right, so finding the slope using 2 data points. Now, to do this, you have to first label your coordinate as x1, y1, x2, y2. All right, and using your slope formula, which is y2 minus y1 over x2 minus x1. So y2 is -3, y1 is 9, x2 is 7, x1 is 5. So we have -12 divided by 2, and this is -6. So the slope is -6. And next one is similar to question 8. And label the coordinate as x1, y1, x2, y2, and using the slope formula, which is y2 minus y1 over x2 minus x1, we have -2.28 minus 3.26. You have to be careful here when you have a lot of negatives. And we have -9.66 minus 4.99. So -2.28, negative will be positive. Okay, if you multiply negative by negative, that becomes positive. So this part is plus 3.26, -9.66 plus 4.99. Now we do the math, we have -2.28 plus 3.26 is 0.98. Divide that by -9.66 plus 4.99. We have -4.67. And if you divide the two numbers, 0.98 divided by -4.67, we have -0.21. It says round to 2 decimal places, so -0.21. And because this is negative, the line is decreasing. All right, question 10. Here we have to write an equation of the line in slope-intercept form. So slope-intercept form is the linear function. So in the form y equals mx plus b in terms of, so using v and t as well the variables in the equation. So v is the dependent variable. We need to find our recurring change, which is $80. Okay, how the amount is changing with respect to the time. Now, because of the depreciated, the slope here is what? Negative. So your slope m is -$80 per year. And your starting value is, so your b is the 880. So your equation is v equals -80t plus 880. All right, you can also write this as 880 minus 80t. Okay, these two equations are right. And we have V equals negative 80t plus 880. Now, using this equation, we can figure out how long it takes the machine to depreciate to $0. So we've been given the $0, which is the V, and we need to find what T. All right. So here we have to what? Or you can also do 0 equals negative 80t plus 80. Either we're going to get the same result. So here we have to subtract 880 from both sides of the equation. So you have negative 880 equals negative 80t. Divide both sides of the equation by negative 80. And your time here is so it will take 11 years for the machine to depreciate to $0. All right, next is question 11. Now, question 11, we have to find the average rate of change. And for average rate of change, okay, average rate of change of the number of trips per year. So here we have to come up with two set of data points and then use our slope formula to figure out what the slope. The slope is the same as what the average rate of change. Now, how the number of trips is changing with respect to the years. So per means divide. So the number of trips is your y, the year is what your x. So you begin with the year followed by the corresponding y. You begin with the year 2006 followed by the corresponding y. So you have your ordered pair. So now you're going to label this as x1, y1, x2, y2, using the slope formula y2 minus y1 over x2 minus x1. We have 26.2 minus 45. Divide that by 2006 minus 2004. So it's negative 18.8 divided by 2. That is negative 9.4. Now moving on to question 12, here we have to come up with an equation that describes the relationship between x and y. So we can come up with two ordered pairs. So we have x and y. So we take 0 and 68, 1 and 61. Label your coordinate as x1, y1, x2, y2, and using your slope formula to find what? The slope. So we have 61 minus 68 divided by 1 minus 0. And 61 minus 68 is negative 7. Negative 7 divided by 1 is still negative 7. So that is your slope. And now the y value that corresponds to the starting value, okay? The y that corresponds to x equal to 0, okay, is your y-intercept. Okay, we said y-intercept is when your x is what? 0. Okay, when x is 0, the corresponding y value is what? Your y-intercept. So on this equation, or on this table, When x is 0, the corresponding y, which is 68, is our b, or the y-intercept. So our equation here is y equals negative 7x plus 68. All right. Now, another way you can also find a slope if you don't want to do all of this work, you can also do new minus old. So you take 61 minus 68. Okay. And that should give you the constant negative 7 from time period to time period. So 61 minus 68 gives negative 7. 54 minus 61 gives negative 7. 47 minus 54 gives negative 7. 40 minus 47 gives what? Negative 7. So you're going to have the constant negative 7 from time period to time period. And that constant value, which is your absolute change, is your slope. Now 13, I found a nearly perfect correlation between variable A and B, and therefore was able to conclude that an increase in variable A causes an increase in variable B. We need to select the correct answer below. Now the answer here is the statement does not make sense because a correlation alone is not enough evidence to establish causality. So that is A. The statement does not make sense because a correlation alone is not enough evidence to establish causality. So this statement is wrong. Okay, B is wrong because it has negative correlation in there. We are not talking about negative correlation. And for negative correlation, as one variable increases, the other variable decreases. So that makes B and C wrong. And D, correlation does not imply causation, so we cannot also select what D. So the correct answer here is A. 14, we have to define correlation and give 3 examples of pairs of variables that are correlated. Now, correlation is it between 2 variables when higher values of one variable consistently go with higher or lower values of another variable. Now, why is A wrong? A is wrong because it does not correctly define or explain correlation. Now, with correlation, we have 2 parts. We have positive or negative correlation. With positive correlation, both variable increases at the same rate, whereas with negative correlation, as one variable is increasing, the other one is decreasing. All right, so the first one for part A, or the option A, it correctly defined what a positive correlation is, but with negative correlation, both variables do not decrease together. Okay, one has to increase and the other has to decrease. C is also not right because correlation does not imply causation. D is also not right because it only defined negative correlation and did not define positive correlation. So that makes B the correct answer choice. And the examples we have here, the amount of smoking and lung cancer, height and weight of people, price of a good, and demand of the good are examples or pairs of variables that are correlated. Now 5, we have to select the answer below. You can make this graph larger, and as you can see that the line, the data points are declining or decreasing. So there is a strong negative correlation, okay? If you enlarge it, you see that most of the data points, if you have to draw a line through the data points, you can see that most of the dots will fall on what? The trend line. And because we selected strong negative correlation, the definition has to go with that. Okay, the answer choice we pick for B has to go with what the answer choice we picked on A. So heavier cars. Okay, so heavier cars make the same. So we need to select a good answer choice. So heavier cars generally get lower gas mileage. Okay, as one is increasing, the other one has to decrease. So heavier cars generally goes with lower. So heavy and lower. Now here we have our equation, and we're going to pick the slope from this equation. Right, the coefficient of x is always what? Our slope. So 102.38 is our slope. 102.38. And what does that mean in context? All right, here we are looking at the amount the government spent per capita on social programs. So the entitlement spending per capita is changing by 102.38, which is the slope value. And with the unit or the labels, we are looking at how y is changing with respect to x. So y label is $2011, and your x label is what? The years. So this is $2011 per year. Now, next one, we have to find the y-intercept. For y-intercept, we have the equation, and your b value is your y-intercept, or you can set x equal to 0 in the equation you find on the graph, and the value that you have left is your y-intercept. So this is negative 135.13. So do not forget to put negative sign. And what does this mean? This means that the average striker per team per game. So this is C. All right, anything that has 4.5 is out. This is out. This is out because the y-intercept was not at 4.5. And here to find the y-intercept is when your x value is what? 0. So common error is what? The CE, which is the time. So when your x is 0, x is your time or the independent variable, your y-intercept is negative 135.13. So this is C. Now describe the basic differences between linear growth and exponential growth. Now for linear growth, your absolute change stays the same from time period to time period, whereas with exponential growth, your relative change stays the same from time period to time period. So the correct answer choice is A. 19, we need to figure out the growth in inflation, whether it is linear or exponential. Now, with exponential, we are looking at what? Increasing or decreasing by a constant percent each time, all right? And with linear model, we are looking at increasing or decreasing by a fixed amount, okay, each time. So because of the percentage, okay, we have an exponential. We are increasing by a constant percent each month. So this makes this an exponential. And to be more specific, this is an exponential growth. So to answer the next part of the question, we have to use the exponential growth equation. And this is on your formula sheet. You don't have to memorize it. So for the exponential growth equation, you need to have some initial amount. you need to add the percent change to a 1. Okay, don't forget to convert the percent change to a decimal, and you need your time t. So we have 140, 1 plus the percent change, 20% to a decimal is 0.2, and you have your time to be 3 months. So 140 1.2 exponent 3. So we have 1.2 exponent 3 and then times 140. And to the nearest dollar, we have $242. All right, question 20. A person earns $18,200 one year and get a 5% raise in salary. What is the new salary? So we have a percent increase. So we are increasing by 5%. So we have to add to 100. So we have 105%. And then we don't know the new value, but the old value is the 18,200. All right, we have P over 100 equals our new divided by old. All right, the new is our new salary, which is unknown, and the old value is the previous salary. So 105% multiplied by 18,200 will give you the new salary. This is 19,110. Now, another way you can also solve this, if you don't like this method or this approach, you can find the increase by multiplying 5% by 18,200. This gives an increase of $910. And then you add that back to the 18,200. And that gives you the same result, $19,110. All right, here we have simple interest. All right, we need to find the amount of money you have at the end of the 30 years. So first we need to figure out the interest and then add the interest back to the principal. Okay, so the amount is your principal plus what the interest. And the interest here is simple. So with simple interest, you need to have your principal times the rate times what the time. Principal is 1,000, the rate is 7%, which you have to convert to a decimal. So we have 0.07. Your time is 30 years. So this gives an interest of $2,100. And then we add that back to the principal to get the amount at the end of the 30 years, which is $3,100. So you started with $1,000. At the end of the 30 years, you go home with $3,100. All right, question 22, 22A. You want to compute the amount of interest you gain after 1 year. So here to do that, we have to multiply the $2,000 by the 0.052. So you have to convert the APR to a decimal and then multiply by what? 2,000. So 2,000 times 0.52 gives you $104. Mm. 2,000 times 0.052 will give you $104. Now, alternative approach will be you can find the amount, which is 2,000 plus 0.052 exponent 1. This gives you an amount, and then you can subtract. You get $2,104. And then to find the interest, you have to subtract what you started with from this amount. And that should give you the same thing. All right, so at the end of the first year, this is your ending balance. And that include what? Interest. You started with 2,000. You have an ending balance of 2,104. So that difference gives you the interest. Now, this is the same as multiplying 2,000 by what factor? Now, the factor is whatever you have in this parenthesis. So 1 plus 0.052. So that's your growth factor. 1 plus 0.052 is 1.052. And that is your growth factor or your factor. Now we need to complete a table. So we've already computed the interest for the first year and the ending balance for the first year. So the ending balance is the $2,104. The interest is 104. Now what you end with becomes your new. So 2,104. And then you multiply by multiply 2,104 by 0.052 to get the interest. And then you add that to 2,104 to get the ending balance. And this is 2,213.41. All right, so you take the 2,104, you multiply by 0.052 to get the interest, and then you add that back to, so this gives you the 109.41. And if you add it back to the 2,104, that gives you the ending balance. And you repeat the process so you finally get to the end of the table. So the ending balance for the second year becomes the beginning balance for year 3. So 2,213.41. Multiply that by 0.052 to get the interest. So the interest here is 115.10. And then you add that back to the beginning balance. plus 222328.51. Question 23. Someone invests 3010 in an account at 4% interest compounded annually. So this is a compound interest question. So we need to write an equation. So compounded annually, you are doing this once a year. So your n is 1. So with your equation, remember the compound interest equation. Okay, this is on your formula sheet. You can always refer to that for that. We have 3010, 1 plus the rate is 4%. You have to convert to a decimal. Your n is 1, and you have 1 times your t. So 3010, 1 plus 0.04 exponent time. So the factor is whatever you have in the parenthesis. So 1 plus 0.04 is your factor. So this is 1.04. And what does this mean in this situation? This means that the account increases by 4% per year. The initial amount is 3010. And this means that the initial amount in the account is 3010. What will the account value be in 14 years? So using the equation, in place of t, you plug in 14 for t. So you have you want to type everything in all at once. So 3010, 1.04 exponent 14. This is 5212.35 cents. 5212.35. Okay, it says one of our responses is wrong. Let's go see. Okay, let's try and divide this by 1 and see if Pearson will accept that. Okay. Sometimes Pearson is picky as to how to type your result. So let's simplify this further by just putting 1.04. Let's see. There we go. So Pearson wants us to simplify it as much as possible. So don't be like me. Make sure you simplify whatever you have in the parentheses. So you put 1.04 instead of typing it like we had at the beginning. All right, next question. So we have another compound interest question. So first, you need to refer to your formula sheet and write down your compound interest formula. We need to find the total amount accumulated after 4 years. So B or A is the same thing. Amount or balance is the same thing. Okay, it's just variables. So if you see A equal to P times 1 plus R over NNT is the same thing. So P is $2,500. We have 1 plus, the rate is 2.1%. You have to convert that to a decimal. This is 0.021. Divide that by 12. If you are compounding monthly, you are doing this 12 times in a year. So your n is 12, and the exponent you have 12 times 4. All right, so you can always compute the exponent ahead of time. So we have 2,500, 1 plus 0.021 divided by 12, and then exponent is what, 48. So you put this in your calculator. Make sure you type it in correctly to output the correct result. We have 2718. So if you do this correctly in your calculator, this should give you 2718.87 cents. All right, if you're getting something different from this value, that means you might be typing something in wrongly. You have to double check how you type in it in your calculator. Now remember that the amount here include what? Interest. Okay, the amount that we found, which is 2718.87, this one include what? Interest. You started with $2,500. At the end of the 4 years, this is your account balance. So to find the interest, your balance minus the principal. So 2718.87 minus $2,500. This is 218.87 cents. $25. All right, we have two scenarios. David won a photography contest and received $1,125 cash prize. Will he earn more interest in 1 year if he invests his winnings in a simple interest account that pays 6%? So for simple interest account, the principal times the rate is 6%, convert that to a decimal, and your time is 1 year. So that interest is 67.5. Now the other option is an account that pays 5.75% interest compounded monthly. So because of the compounded, we need to find the balance using the compound interest formula. And then subtract the principal from the balance to get rid of the interest. So we have still 1125. 1 plus the rate is 5.75%. You convert that to a decimal. 0.0575. Compounded monthly, your n is 12. You are doing this 12 times in a year, and you have 12 times what? 1. So this is 1191.42 cents. 1191.42 cents. Now this include what? Interest. So to find the interest is 1191.42 minus 1125. This is 66.42. So option 1, option 2. Which account will he earn more interest? So we have a difference. It says round to the nearest dollar. So this is $1. So if you take the difference between 67.5 and then 66.42, you have $1.08. And if you round this to the nearest dollar, that is just $1. So this one is higher. The simple interest account is higher. So he will earn $1 more interest in the simple interest account than the compound interest. Now, credit card, we need to find an interest earned on the balance you have on your credit card. And this is the finance charge we talked about. So to find that, we have to divide the APR by 12. We have to convert it first to a decimal. So 17.5 divided by 12, 17.5 divided by 100 gives you the decimal of 0.175. Divide that by 12, and then you multiply by the balance on the credit card. So we have an interest of 55.72 cents. And the new balance, so the interest will add up, and whatever payments you make, you deduct. So 3,821 minus the payment of $850, and with the interest that adds up, so you add the interest to that. So this is 3,821 minus $850 and then plus 55.72. We have 3026.72 cents. Point is 7. An individual borrowed $88,000 at an APR of 7%, which will be paid off with monthly payment of $699 for 19 years. Now, we're going to use the information provided to fill in the blank spaces we have. Now, we know the amount borrowed is $88,000, so that is what you put in this box. The annual interest rate is 7%, you put 7. The number of payments per year is just 12. The loan term is 19 years, and the payment amount is $699. And how many total payment does the loan require? And what is the total amount paid over the full term of the loan? Now, the number of payment or the total payment, if you're making a payment of $699, okay, each month for 19 years, okay, at the end of the loan term, the number of payments you've made, okay, the number of payments you would have made will be 12 times what? 19. All right, we have 12 months in each year. So each year you have 12 number of payment, you multiply that by what? The 19 years to get the total payment the loan requires. We have 228. And here we need to find the total amount paid. So this is the same as the total payback. So if you're making a payment of $699 each month for 19 years, at the end of the loan term, this is how much you have paid back with interest. So 15,972. All right, so you take the monthly payment and you multiply by 228. So the total paid on the loan is the fixed payment times the number of payment. We need to figure out the percentage paid towards the principal. Now, if you can find one, All right, if you're able to find one percentage, you can find the other one by subtracting from more than 100%. So I always ask students to find the percentage paid towards principal. Okay, you can find that one first. And if that percentage is right, you just subtract it from more than 100 to get the percentage paid for the interest. So percentage paid towards principal. The principal is part of the total payment. All right. So this is an application of what percentage. So you divide the principal, which is the part, by the total paid. Okay, the total amount paid, and then express that as a percent. Okay, so the principal here is the loan amount or the borrowed amount. So you take $88,000, divide by the total amount paid, which is what we found on part B, the 159,372, and then you multiply by what, 100. So 88,000, divide that by the total amount paid, and then multiply by 100. So this is 55.2, nearest 10, 55.2. And since we know this percent, we can find the other percent by subtracting from what, 100. So the percentage paid for the interest is 100 minus the 55.2. And this gives 44.8%. So this is 44.8%. Right? The principal plus the interest is the whole percentage. So if you know the percentage paid towards the principal, you can find the percentage paid towards the interest by subtracting from more than 100. And the last question is the retirement. Okay, this is the future account balance. Now you make $65,000 per year and your company matches 50 cents for every dollars you deposit into your 401k plan up to 7% of your salary. Now, if you contribute $300 every month to your 401k, what will your company contribute each month? Now, for this type of problems, you always need to find the maximum the company will match. So you need to first find the maximum the company will match. So I'm going to start. You take 7% is 0.07. You multiply that by 65,000. All right. Up to 70% of your salary. So this gives $4,550. And you're matching 50%. So you take half of that. And this is for the whole year. So you have 2,275. And then since we are looking for the monthly or the maximum the company will match each month, you divide by 12. And this is 189.58. All right, so this is the maximum monthly contribution. Okay, that is the limit. Okay, that is the limit. Maximum monthly contribution by the company. All right, there is a threshold or there is a limit to how much they are going to contribute up to. So if you make a contribution and after the match, it is higher than this value, they are only going to contribute this maximum amount. So for the $300, 50% of the 300 is just what? 150. And since that is lower than the 189.58, they are going to contribute all the amount. Now, when it comes to the second one, 50% of $780. This is $390. This is higher than the $189.58 they are going to contribute up to. So the company is going to contribute the $189.58. And the last one is the maximum amount the company will contribute each year, which is what we already found. This is the 2275. If you divide 4550 by 2, if you take 50% of 4550, that is the maximum amount the company will contribute each year. All right, this is all the questions we have. These are all the questions we have on the exam 2 review. So go through it and reach out if you have any questions or concerns. Thank you.